Pagi Bu Ani.
J, Pak Nur J.
G, sudah
Oh, J.
masuk.
Sebentar.
Di presensinya sudah masuk G.
Oh, J. Tidak harus presensi, Pak. Ini untuk mahasiswa.
Oh, enggak harus.
Tidak harus. Tapi ya tidak apa-apa. Ada catatan.
Berarti mesti buka itu.
J, nah ini sudah hadir Pak Nur di tengah-tengah kita. Baik, mungkin langsung saja, monggo. Saya persilahkan Pak Nur.
Baik.
Dan Pak Kaputan nanti tidak bisa menunggu, J, Pak.
Ya, enggak apa-apa Bu Ani, monggo.
Ya.
Oke, partisipan 14. Hanya 14 peserta ya Bu Ani ya?
Ya, terus Pak, ini ada dari IUP, ada dari reguler, kemudian juga ada adik-adik dari UDINUS, Pak.
Oh, gitu ya.
Ya.
Oke, bentar saya lihat dulu. Oke, nah sebentar saya pasti pakai headset dulu. Okay, good morning, everybody. Today we learn about the trend in computer science. My topic is outlier detection and its application. So, sorry for my PPT, that is I use Bahasa Indonesia. Since I think all of you are Indonesian student, but Bu Ani told me that there are some in IUP student. So even though I have PowerPoint in Bahasa, but I will explain in English. So for you in the IUP class, you may ask me whenever you got some maybe strange words or you do not understand about some of my expression or my statement. Okay. outlier detection is actually part of data mining. So in the beginning, I will tell a little bit about the data mining, such that we may have a relation between data mining and outlier detection. Since I think data mining is more familiar for you, yeah. So we start the lesson with the data mining first, just to make you remember about the data mining, and then what relation data mining and the outlier detection. Okay. Okay. Data mining actually is a process of extracting knowledge, from a database, but usually a big database. So we may call the big data. So extracting knowledge from the database, from big data, it's called the data mining. And actually, in data mining, we use many kind of other knowledge, other science. It's mean, math, statistics, or computer science. The knowledge itself are patterns or model. So whenever we refer about the data mining, actually we mine knowledge, not data actually. And this is a familiar model of what is data mining itself. What are the process regarding to data mining? We are here, we have database here. This is databases, and maybe we have many database incorporated in the data warehouse. So there are many database comes from many shoots, from many places. So we unified the database into the data warehouse, even though it's only in the data that we unified, but the place maybe it's separated far. So from the database, we built data warehouse, and then we do the data mining, and we got the pattern. Pattern here actually is the knowledge. Patterns mean the relationship between the data or maybe between the variable representing the data, that is knowledge. So there are many steps in the knowledge discovery. Yeah? Data mining is also called the knowledge discovery. There are many steps in data mining. The first one is data cleaning. The second one, data integration, and then data selection, data transformation, and then data mining itself, pattern evaluation, and knowledge representation. In the first step, data cleaning means we try to find any noise or any inconsistent data. And then we delete or we omit the data that is not consistent or maybe noise, such that we have clean data and ready to be mined. So data cleaning, yeah, omitting the noise and the inconsistent data. And then from many sides of the data, we integrate into the data warehouse, and then we select the relevant data, we transform the data into a forms that can be mined. Since maybe the algorithm that you use need some form of data, then we transform first before we mine the data. And where is the outlier detection? Outlier detection can be part of the data cleaning, since outlier mean data that is far from the normal data. So outlier may be part of the noise or inconsistent data. So this outlier detection is the first step. The first step or the first part, yeah, the part of the first step from the data cleaning. And this is the definition of outlier. Far away from the normal data. In this picture, we have two groups, namely N1 and N2. We have N1 and N2. So most of the data separated into two big groups, that is N1 and N2. But there are two data that is far away from both N1 and N2. Yeah. this point O1 and this point O2, it's lie on the far part of the N1 and N2. So this is a kind of point outlier. But also here we have a group of data, far away from both N1 and N2. So this group, this small group, is called the outlier 2. This is outlier for 2 dimension. This is an outlier of 2-dimensional data. When we process data like this, the outlier O1, O2, or groups O3 will significantly make the result may be wrong. May be wrong, since if we have some maybe the average, then this data, this outlier, will affect the result in a significant and insignificant number. But if we could detect this data, this outlier, then we have 2 uniform data, 2 groups, and then it will in the position that is uniform. So it is very important to detect this outlier, and then we may perform some operation that we do not use this outlier data. Outlier itself, if introduced by Sinchi in 1987, even though the outlier itself more discussed in the latest year. But Sinchi just define outlier for a one-dimensional data. Suppose we have X. X is a set consists of n number, n real numbers. X1, X2, Xn. This data can be represented in a line. And then we may have the what we call the interquartile rings. Yeah. We have average, the upper quartile, lower quartile. Suppose key B is the lower quartile, key A is the upper quartile. Then the interquartile is the data that is lying in the interval between key B and key A. This is the interquartile rings. Also, we have another definition, since he define what we call the inner fence. Inner fence and the outer fence. Inner fence mean the data that is lie below the quartile, the lower quartile, below the lower quartile, to key B minus 1.5 of its QR. QR means the distance between key A and key B, the upper quartile and the lower quartile. That is the inner fence. So since he divide the line into the inner quartile things and then the inner fence, inner fence and outer fence. The inner fence itself, we have the lower inner fence, that is this one, below the lower quartile, and the upper fence, that is the above the upper quartile. And the outlier data are the data that lie in the outer fence on or others. If we have the outer fence or others, then we have the outlier. Okay, any question? Any question?
No, sir.
Okay.
Not yet, sir.
Okay. So since he defined the outlier for the one-dimensional data. And the thing about this, we have two-dimensional. So you may imagine why O1, O2, or O3 are called the outlier. Do you have any idea why O1, O2, or O3 are called the outlier? Do you have any idea? How could O1 or O2 or O3 are called the outlier? Any idea? Yeah, it's lie on the far part. Yeah. The distance, yeah, the distances are far from the groups, the bigger groups, like this. Far, yeah, far away. So defining the outlier, we need, yeah, we need the distance to measure, yeah, to measure, to calculate the distance. Yeah. This is the one-dimensional, and this one two-dimensional. And actually, for the bigger dimension, it's still in a research for the bigger dimension. Since for the bigger dimension, we have many calculation, and also we'll have the complexity, yeah, the higher degree of complexity. And what is the importance of the outlier detection? It comes from the outlier itself. Since, yeah, for the positive things about the outlier may indicate that there are new facts. Yeah. There are new facts. That is the positive, yeah, the positive impact of outlier.
Excuse me, sir.
Okay.
You're not sharing your screen.
Oh, wait a minute. Okay, is it on your screen?
Yes, sir.
Okay. Okay, wait a minute. Okay, here is the importance of the outlier. Actually, yeah, we have positive, yeah, positive impacts of the outlier and the negative impacts of outlier. Outliers can be can indicate, or outlier can be indicator that we find new facts. Yeah. But on the other hand, we have negative outlier. That means outlier indicates, yeah, that maybe there is an error for the system, or maybe any intrusion in the system. Or maybe yeah, some maybe part of the machine that is leak. Yeah. So we have two kind of outlier. In this, yeah, in this picture, yeah, in this illustration, yeah, we have N1 that is we call normal. Why it's normal? Since there are many data lie in here. And two, we call this data are normal. Since many data here. And how about O3? For the small number, for the small number of data, it view as the outlier. But if if we got new data, new experiment, new data, and then the result lie on the O3, then the O3 getting bigger and bigger, more and more data here, and then after some threshold, O3 become the normal one, and the normal data. So whenever we found an outlier, we have to think that there are two possibilities, positive outlier or negative outlier. Positive mean maybe the new, the outlier reflecting new fact, new knowledge. And this negative one, whenever the outlier comes from the error nodes, the error of the system. And there are many applications of outlier detection. The first one in the biology, in signal processing, maybe in the credit card fraud detection, we may use the outlier detection. In the flight system, identification of some part, predicting the weather, in health, and many other. This is the research conducting by many researchers. You may browse the, may Googling this researcher. Okay, before we continue, I think we need some exercise, by using this definition. Okay, I stop sharing. Okay, I insert data. Insert. Okay, I give you data here. Please find the upper quartile, lower quartile, and then please find whether there are outlier in this data or not. Okay. According to the Sinci definition. Okay, I give you 10 minutes to find the outlier in this data. Okay. Oh, sorry, 10 minutes only. Okay, 10 minutes from now, please find the outlier. Okay. Any question?
It's clear, sir.
Okay. So whenever we work with data, yeah, we have to use many definition, many formula, yeah, to uh, to detect the outlier. Yeah. It's turned out here that 3 is not outlier, but 20 is an outlier. Because whenever we calculate the quartile, and the upper quartile and the lower quartile, and then the inner fence, it turns out that the inner fence, yeah, the inner fence range from 2.5 to 7 or 10 to 14.5. So 3 is lies in the inner fence. So 3 is not outlier. This is the simple way to detect the outlier. So whenever you have data as an input, and then finding the outlier, yeah, first we calculate the quartile, yeah, and then construct the inner fence. Okay, what is on your screen? My PowerPoint?
Yes, sir.
Okay. Still this one? Okay. Uh, we may categorize many outlier detection. The first one based on the data model. We have 3 categories of outlier detection method based on the data model. The first one is called the supervised outlier detection. The second one, the semi-supervised outlier detection. And the last is the unsupervised outlier detection. This categorized based on the data model. The supervised outlier detection, in the supervised outlier detection, we have data model for the normal and for the abnormal. Maybe the distribution of the data, statistical distribution, and so on. So for the supervised outlier detection, we have 2 data model which representing the normal data and the abnormal data. And whenever a data processed by the outlier detection, then the method can determine whether the data is in the normal data or in the abnormal data. That is the supervised outlier detection. This outlier detection use the neural network, artificial neural network, statistic, and maybe a rule-based model. This is the supervised outlier detection. The second method is the semi-supervised outlier detection. In this method, we only have the normal data model. We only have the normal data model for the semi-supervised outlier detection. So whenever a data come to be processed by the outlier detection, then the method could only determine whether the data lies in the normal data or not. We only could determine the data is lie on the whether the data lies in the normal data or not. But we could not determine that whether the data in the abnormal. We could not determine this. We only could determine that the data is in the normal model or not. That is semi-supervised. In this category, we have support vector machine, hidden Markov model. And the third method is the unsupervised outlier detection. We do not have both the normal data nor the abnormal data. So in this method, we identify the outlier by comparing the data with the others. We compare the data with the others. In this, we have k-mean, local outlier factor, and dp scan. In this illustration, the determination of O1, O2, and O3 being the outliers since we compare it to the others. And when the data crowded here in this area, and two, the data crowded here. So this not outlier And these are outliers since this data far away from the N1 or N2. O2 outlier since it is far away from the N1 or N2. O3, this group of data are called the outliers since those data far away from N1 and N2. But in this case, we have no model about the data. Also, in your exercise, we only have the data. We do not build the model. But here, you could find the outlier. Since it turned out that 20 is far away from the crowded of the data. 20 is far away. So 20 is outlier. In this data, we do not have any data model. Okay. And then we have another way to categorize the outlier detection method based on the data type. We have three kinds of outlier detection method based on the data type. Namely, the first one, the outlier detection for the numerical data. The second, the outlier detection method for categorical data. And the third one is the outlier detection for mixed type data. For the numerical data, we also have many categorization. Here, I present three methods of the outlier detection for numerical data. First, for the based on the cluster. The second one based on distance. The third one based on density. And here, the development of the outlier detection method for categorical data. Yeah. Beginning from 1990, when Agrawal talked about the frequent item set, from the frequent item set, and then Agrawal divide the data, into the frequent and infrequent. The infrequent data is the outlier. And then many development has been done by the researcher, by using the definition, by using the hypergraph LSA, AVF, attribute value frequency, SCF, CNB, and on each of the method, then many researchers continue to develop the outlier detection method. And this is the tree representing how the development of the outlier detection for the categorical data. Okay. And this one, how we develop the mixed attribute. Yeah. For the mixed type data, the mixed type mean we have the categorical data and the numerical data. We categorize the method into four method of the mixed attribute outlier detection. The first one is called the categorize outlier detection method for mixed attribute. It means we have mixed type data, and then we separate the data. Yeah. PC mean the categorical data, PQ mean the numerical data. And we use F function to transform the data from numerical into categorical. And then we use the categorize outlier detection for this, for this data. So we transform the numerical data into the categorical data, and then we do the outlier detection. And then the second method is called the enumerated outlier detection method for mixed attribute data. In this method, we separate the categorical and the numerical. And then for the categorical, we transform using G to transform the numerical data into the G is used to transform the categorical data into the numerical data. After that, we use the outlier detection for numerical data. Yeah, ODN mean outlier detection for numerical data. So transforming first the categorical data into the numerical data. Finally, we have numerical data for all, and then do the outlier detection. The third is the combined outlier detection method for the mixed attribute data. In this case, we separate the categorical data and the numerical data. And then use the ODC, outlier detection for the categorical data, and use the ODN, outlier detection for numerical data, yeah, both separately. After that, after we detect the outlier, and then we combine. We combine the result such that we find the outlier data. And for the fourth one, the mixed outlier detection, use some method RNN to unify the data, to transform the data, such that we could, yeah, detect the outlier by transforming the both the data, the categorical and the numerical data. And the latest development of the outlier detection is held by the Sanja Priselak in 2022. Yeah. That is outlier detection for mixed attribute data. Okay. I think that's all, and then we have discussion. Okay, please raise your hand to start the discussion. You have any question? Apakah ada pertanyaan?
All clear, sir.
All clear. Okay. Bagaimana yang lain? Only Chris. Answer my question. Okay. Oke, sekarang bagaimana dengan mendeteksi ini? But I don't have the data. Okay. Is it on your screen? Anomaly detection survey. Outlier detection, sometimes called also the anomaly detection. Yeah. Outlier detection, sometimes also called the anomaly detection. And you should have this survey whenever you want to do the research about the outlier detection. And here's the anomaly. And I want to show you that when we talk about the anomaly, yeah, or the outlier, we could have what we talk is called the anomaly point or point anomalies. It means we only view data as a single, yeah, as a single entity. that is point anomaly or point outlier detection. But we also have what we call the contextual anomaly or contextual outlier detection. So for this picture, yeah, for this graph, we have data that is like a peak. Yeah, we have peak here, and then go down, and then up again, reach the peak. So the normal data we have up, peak, down, up, peak, down, and so on. We view the data as a context, not a single data. Since if we view the single data, maybe this one be outlier. But whenever we use the context, then this is normal. Yeah, up, peak, down, up, peak, down. That is normal. And in this context, yeah, we got the outlier or the anomaly for the T2 like this. Since the value drop in a sudden, yeah, up before reach the peak, down here, and then up to reach the peak. So this is outlier. But if we use only the value as a single, T2 maybe cannot be viewed as an outlier. But after we use the contact, then T2 is outlier. This is also outlier for the red. Yeah. Outlier for the reds. Since we have the graph like this, yeah. But this is, yeah, we do not have it in this context. So in this case, we detect the outlier after we have the context. So you should pay attention of the data itself, whether it is single data or the contextual data. Yeah. Okay. So I think that's all. I hope this introduction gave you a brief knowledge about the anomaly and its development. And still there are many parts that you may contribute. Yeah, you may contribute, yeah, to fulfill any parts of the outlier detection knowledge. Okay, I think that's all, and hope you are success for for your thesis whenever you take this subject. Thank you. Oke, terima kasih ya. Sudah cukup untuk deteksi outlier ini. Oke. Ya, terima kasih sama-sama.